Okay, so as we look back over the last kind of 3 weeks, I just want to quickly show you all the stuff we've been learning about, and we're going to use it in today's lesson. So the first thing was distance formula. In fact, let me use a different color here. Sure. Let's use some yellow. So we talked about the distance formula. We spoke about the gradient formula. We spoke about the midpoint formula. We spoke about the angle of inclination, and we talk about the equation of the straight line. So those are the main things and tools that I think from being here, you will have in your toolkit to work with. Now, what we need to be able to do is apply these tools to particular things. So find the distance between 2 points, prove a triangle is isosceles, equilateral, or right angle. We're going to do some of that stuff today. Prove something's a parallelogram. We'll talk about that today. But I just thought for those who want to take a screenshot, or for those who like having lists, these are the types of questions that you'll see us covering, but sometimes it's nice to have a bit of a list. So if you want, you can take a screenshot, and yeah, this is the topic in its entirety. There are a few things which we still need to discuss if there's time, like collinear, proving that, but the majority of stuff we have done. Okay, so let's get started with a question related to the things that are above. Now, I want to ask a question first. The question says, show that the triangle below is right angled. And I want to ask you, before we even answer this, what strategies or methods do you know of that can help me prove this triangle is right angled? And in the angles that we have here, maybe which one do you think is most likely to be the right angle if it is? Like we have this angle here, we have this angle here, we have this angle here. Which one do you think would be 90 if you were guessing? And what methods do you think we could use? So if we look at these ones, I think that the Q is the most likely, but I still need to prove it using mathematics. So I'm guessing Q. So how do I prove something is 90 degrees? Well, in the previous lesson, didn't we talk about proving lines were perpendicular? What did we need to show that lines were perpendicular, which means the same thing as 90 degrees? Didn't we have to work out their gradients? So what I'm going to suggest, yes, Lolita, exactly. So can I suggest, if we suspect Q is our right angle, we should find the gradient of RQ, and we should find the gradient of PQ. So won't you go ahead and see what the gradients are? You're going to use the gradient formula, which I will put up here. And then once you found what you found, I'd love someone to come and tell me whether or not they think it is a 90-degree angle or not. Orokinesis said when you multiply the gradients, they need to be -1 if they are perpendicular. And Annie said reciprocal. Annie, you're almost right. It's the negative reciprocal. So there must be a change of sign. But over to everyone, you find me my gradients. Then we'll go from there. Okay, so I see quite a few things in the chat. We've got, I haven't finished my working out yet, so 2 over -2. I'll give you guys a chance. So if I multiply these two gradients together, what you notice is you get -1. And therefore, angle Q is equal to 90 degrees, or it's perpendicular. Some of you may be saying, where's the negative reciprocal part? Well, just remember that 1 is 1 over 1. So what's confusing about 1 is if you switch them around, it's still going to be, 1 over 1, but then you have to change it from a positive to a negative. And so these are negative reciprocals of each other. It's just that 1 is a bit of a tricky beast. But yeah. Okay. Quick little thumb vote up if you felt like you could follow what I was doing. Thumb vote down if you're feeling a bit like I'm talking another language. Give me a quick little bit of feedback. Okay. Well, let's have another look at a different type of question. This question says, the vertices of a triangle ABC are given. So they don't even give us a drawing. They just give us these points. It actually tells us what tool to use. Use the distance formula to determine the type of triangle. So when we talk about the distance formula, what I like to do is write down all the things that I'm trying to find. So if you look at it, there's the distance between here and here, distance between AR, that's the bottom one then, and then NR. So I want everyone to help me find the distance of each of these lines or line segments, and then we're going to try and calculate the perimeter of this triangle. Okay, so off we go. For those who are feeling a little bit unsure of the distance formula, it's got this structure. So this goes all the way back to lesson 1. And inside of that, we have x2 minus x1, y2 minus y1. I'm going to give you some time to practice that now and get me my 3 sides and then tell me what my perimeter is. I'll do the first one as an example in case you're feeling a bit rusty. So I go like this. For those who are feeling a bit unsure, just watch me do this first one. So now for AN, I go -2 minus -8. Now -2 minus -8 is actually -2 plus 8. And then for the Y, I go -1 minus 9. So -1 minus 9. And so then what I should have is I should have -2 plus 8. So that's 6 squared, so 36. And then this is -10 squared, so that's 100. And I would just leave it in surd form, because surd form is very easy to see and it's easy to work with. So just leave it in surd form. I get square root 136 for AN. Now see if you can do the same thing, but with the other 2 sides. And if you have a question, don't be afraid to pop your hand up. Now is a great time to ask questions while students are working on the material. I like drawing these little lines just to make sure I don't forget things. I might need my calculator for that one. Can somebody help me with this one over here? Oh, I see we got square root 97 NR, so we agree. And then square root 136, we just need to find the length of AR. Okay, so this one over here, Zander said 225, but there's also the 36, I think, that we have to add in, which would give us 261, square root of 261. Yeah. So what we can do is we can use the distance formula to help us work out the length of sides. Now, the final part of the question is to find the perimeter. I'd like you to find the perimeter of the shape, or the distance around the outside. If you've got a triangle, the perimeter would just be like saying, add this length plus this length plus this length. And I think at this point, you can write it as a decimal if you like. Let's go to Lutando. Lutando, what's your question?
Oh, good afternoon, sir.
Hey, what can I do to help?
Isn't the x value of a supposed to be negative when you are calculating the distance?
Okay, so it is, but what's happened was in some of the questions I had minus a minus. So like, let me give you an example. If I look at this one over here, like 7 minus 8. When you have 7 minus 8, it actually becomes 7 plus 8. And that's why in my working out over here, I had a 7 plus 8. So if you look at the formula, there is a minus in the formula. You're quite correct. But if you have minus a minus, it becomes a plus. And so, do you see? Okay, fantastic.
Yeah,
lovely question, Lutando. That was a very good question. A lot of students benefited from it. Okay, so pleasure. Guys, that's a great question. That's exactly the sort of question we should be asking for us all to keep learning. Okay, so what is my final perimeter? So if you go square root 136 plus square root 97 plus square root 261, what do you get? Orokanisa, let's go to you. Can we unmute Orokanisa?
Hi, sir.
Hey, what did you get, Orokanisa?
I wanna ask, like, when I put
Yeah.
the square root for an, I get 2 square root of 34, and I don't understand how you got the 136.
Okay, so give me what you've got. You got
2 square root of 34.
Okay, so what you've got is your calculator has put it into surd form, which is equivalent. Can you find the little SD button on your calculator?
Yes, sir.
Push that button and see what happens. Does that help you? Does it change?
Oh, wait, let me.
Because it is the same thing. So.
Oh. Okay, I see. Thank you,
Perfect.
sir.
No, good question again. You guys are coming with great questions. So this is the same as this. It just depends on how you keyed it into your calculators. I would mark it correct. It's not that this is wrong and this is right. Both of these are correct. All right. And so I want to ask you one more question about this. What type of triangle is this? So if I say to you, you found the perimeter, who would like to tell me what type of triangle is this triangle? Based on what work we've done so far. What are the main types of triangles? We have equilateral, isosceles, scalene, and then if we had angles, we could talk about other types. But in this case, Amakle is asked, how do we get the perimeter? To find the perimeter, all I did was I added up the length of the sides. So I went square root 136 plus square root 97 plus square root 261. You can kind of imagine like the one side's length is that, one side's length is that. Okay, I should have probably made the biggest one square root 261, but you get the idea. So I'm just adding up the lengths. And what everyone can see is that this would be a scalene triangle because all the sides are a different length. And so if you had found 2 of the sides were equal, it would have been isosceles. If 3 had been equal, it would have been a equilateral. Okay, everyone, we're doing very nicely. In fact, we're doing so nicely that I think it's time for another question. So I want to ask you about, oh, Iolo, what's your question? Can we unmute you while I put this new question up on the board?
Evening, sir.
Hey.
Can you hear me?
Yeah, loud and clear. What's your question?
My question is, root 36 plus 100 is not actually root 136. It gives me 2 root 34.
Okay. All that is, it's an equivalent expression, and it's written in surd form. But if you hit the SD button on both of these, you'll see they give the same decimal number. So it's an equivalent number. It's not wrong. It's just the same thing written in a different way.
Oh, but then it gives me 11,66, sir.
Okay. I'm pretty, that's fine, but that is equivalent. Both of those are equivalent.
Yes, sir.
Cool.
Okay.
Awesome.
I get you. Thank you.
Cool. So I want to move on to a different type of question. This question, often they give you a shape and they'll say the shape is a parallelogram. In this case, I didn't actually, I obviously chopped that bit out, but they'll tell you that this thing is a parallelogram. It's going to be PSRQ. And when you write down a parallelogram, you always write down the vertices in order. So that's why I went PSRQ. Now, one of the things about a parallelogram is it has certain properties. Can anybody tell me what some of the properties of a parallelogram are? I've jumped a little bit from triangles now to quadrilaterals, but specifically parallelograms, because they seem to come up a lot in this topic. So 2 opposite sides are equal. Yes, that is property of parallelogram. And another one, Ayanda has said the opposite angles are equal. So that is a good, what else? What about the parallel? Oh, you guys know your stuff. Amakle says the diagonals bisect each other, which means they cut each other. Be careful here, don't go too fast. They cut each other in half. And then the one I was really thinking of was that they have parallel sides. So let me actually get rid of, it's getting a bit cluttered. So if we look at a parallelogram, it has 2 pairs of opposite sides that are parallel, 2 pairs of opposite sides that are equal. And then we also have the angles, but I'll leave that out for now. But we also have diagonals that cut each other in half or bisect each other. Fine. Now, the common question here is, I've given you a missing point, and you have to find the point, given that they tell you it's a parallelogram. And guys, this is such an awesomely easy question to do. And I'm just going to show you my wonderful, easy method to do it. So, because these sides are equal in length, and they have the same gradient, the journey to go from here to here is going to be exactly the same as the journey from here to here. And you may be asking yourself, what is this man talking about in terms of the journey? Well, I want to pretend I'm a random point sitting over here. Well, not a random point. I'm actually the point -2, 3. How much does my x coordinate change to go from -2 to 7? So how much does my x coordinate change to go from -2 to 7? So it goes from -2 to 7, it goes 9. So what we do is we say x plus 9 is the journey, is the red journey, basically, is the one to go from here to here. How much does my y coordinate change to go from P to S? So to go from 3 to 5, I have to go up by 2. Okay, now this drawing is actually a bit out of scale, so it looks a bit wonky. So I don't want you to stress too much about the answer I get, but all I do now is, since I've done the red journey, I'm now going to do, should I call this the blue journey? So I start at -3, 1, which is the one in the corner. And if I start there, I need to add 9. So if I'm adding 9 to -3, so here's the plus 9. So I add 9 to -3, what do I get? So I want to go, I'm going to draw a new point and I'm going to get 6. Yeah. Okay. And then if I want to go from here to here, and I'm going from this y over here, what is this 1 going to have to become when it gets to here? So 1, and I look at my journey and it's +2, and so this becomes 3. So this point over here, the point on the parallelogram has to be the point 6, 3. Now I'm just going to go over that one more time so that you get the method that I'm using. I said that because this is a parallelogram, opposite sides are equal and parallel. And so to the journey that this red part goes on, to go from this vertex to this vertex, it must be the same journey that Q goes on to get to R. And so what I did was I made a little journey rule. And I said, I'm starting with X, Y. What do I need to do to go from here to here? And then I used that same rule on -3, 1. Now, the best way to see if you've got this is to practice. So let's do another one. One more trick, though. The order of the parallelogram has to stay in the order that's given. So here it says A, B, C, D. So A, B, C. The D has to be over here. The D can't be up here and it can't be up here because that would change the order. So I want you, let me just make that clear again. You need to make sure you put the point in the correct quadrant. And the only way that you can keep the order of A, wait, I lie, have I done it wrong? A, B, C, this point, I'm actually making exactly the mistake I was talking about. So A, B, C, in order for D is going to have to be up here. Can you see how that preserves my order? Now, I want to figure out what, it says state the coordinates of D so that A, B, C, D is a parallelogram. I want to ask you, what are the 2 points I need to focus on first before I worry about D? Who has any ideas? In fact, maybe someone can come on and tell me. Who thinks they know what points I have to focus on first? Let's have a look. Who feels like they know? Pop it in the chat, or you can raise your hand if you're feeling gregarious. Samokuluhle. What do you think? Can you hear me? I think maybe we've had a bit of an audio bug there, but I see lots of you say, okay, I think the best thing to practice, to focus on, oh, is that someone there? Can I hear you? Okay, maybe we've had an issue there. You first focus on B and C because they tell you the journey. Then once you've got the journey, you kind of get your GPS from them. And then once you've got your GPS dialed in, you know how to get to D. So what I do is I'm going to start at B and I want to get to C. And I want to know what is the rule that I have to do. So I need to go X plus something, and that X plus something is indicating the journey from -2 to 5. So who thinks they know, how do I get from -2 to 5? Annie, I'll explain in a moment. Let's just do this one and then I'll go through that again. So how do I get from -2 to 5? I think I need to increase x by 7. So I'll go x plus 7. And then to go from y is 0 in B, oh, let me bring that back. I don't know where that went. To go from y is 0 to y is 3, it feels like I just need to go plus 3. So that's the GPS. That's how we get there. Now we're going to start at 0, 6, and we need to get to this point D. What is my point D using the rule that I was showing you? So the very first one is going to be a 7. So for this coordinate here, D is going to be a 7. And then what's the next one going to be? Yeah, it's going to be, oh, I see you guys are getting it. So this is going to be 9. And you can kind of see that it fits, in terms of this drawing over here. Okay, so we'll do one more after the break, but finding the missing point in a parallelogram is actually not that bad as long as you remember, get your GPS directions and then apply them, and then you're good to go. And the reason, Annie, that I had to start with B and C is because I had a matching pair at the bottom here. And so you could have also, though, you know what, actually I've realized, guys, you could have gone from B to A and then said, go from C to D, and that would have worked as well. So some of you said earlier on, you would have chosen A to B. It's actually not wrong. It's just that you would have had to write down a different rule for directions. And then once you've got that rule for directions, you could have used that to get from C to D. Yeah, Mayton, what's your question? Can we unmute Mayton if his hand is up? I don't know if your hand is up, Nathan. Okay, I tell you what, we need a break because we've been going solid for a while. So I'll come back to that after the break. I'm also going to make sure that my lights are on. And I want everyone to stand up because we are all human beings here today. And so we need to recognize that there are limits to our concentration. And so we have to take care of our brains so our brains take care of us. All right, let's stand up, swing those arms, maybe do some circles, maybe do some twists like this, whatever feels nice and free and relaxing. I know for me, I can definitely feel the difference. Let's do some of this. And make some smaller circles. And then what I like to do is I reverse the direction. So I reverse the direction and then I go big. Okay, and then in my case, I always stretch my shoulders, but if there's a stretch that you like doing, feel free to do that as well. I just find my shoulders get a bit tense when I'm leaning over my computer. So the stretch is nice and I just feel my back muscles saying, oh, thank you. And then one we haven't done for a while, I don't know if I can still do it, but actually this is a great one when your shoulders are hunching. So like a tricep stretch. Oh, that feels fantastic. Okay, and let us do, make sure I don't hit my lights. Okay, make sure you've got some space. We're just going to do 10 jumping jacks. So jumping jacks are like this, 1 and then back. So we're going to do 10 and we'll start in 3, 2, 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and sit down. Oh, definitely feel like my body is happier with me now. So for our brain break today, we're just going to do at least one of these, but maybe 2 if there's time. You need to make 24 using the 4 numbers on the screen, on the card. See if you can find a way of getting to 24, and take note that this is a 6 as far as I can tell. The line's always at the bottom. So that's a 6. Who can find me a way to get to 24? Let's just do the red card. If there's time, we'll do the blue one, but mainly we're just going to do the red. Okay, Fabian is on the money. 6 times 3 plus 5 plus 3. So that's 18. Wait, did we get there? No, that's 26, eh? Be careful. Because, so I false. So that's not quite right. Annie has said 5 times 6 is 30. So I've used those two, and then I go 30 minus 3, which is 24. And then Sachaba has said 5 times 3 is 15 plus, wait, 5 times 3 plus 6 plus 3. Oh, that also works. Aha, yes. So both, there's actually more than one way to do this. Okay, guys, I'm actually not going to do, because we're a bit pushed for time today, I'm not going to do the second card right now, but I think you've done really nicely. We've had a nice break, and you've hit the Math 24 out the park. So let's go back to our lesson. So let's do, let's do one more like this. So I want you to find me the coordinates of H such that H is a parallelogram. And just to make sure my order is correct, A, B, C, H is going to have to be out here somewhere, I suspect. A, B, C, H. And then there was also a question from Matate, I think. I don't know if you're going to put your hand up again while students are working on finding H. And then I can come to you. Or Mayton, sorry. Mayton, can you hear me?
Yes, I can hear you, sir.
How's it going?
So,
What can I help you with?
sir,
Yeah.
agree. We all know that both diagonals bisect each other in a parallelogram. So,
Yeah.
in the previous question, can't we just use? I can't say it properly now.
No, I know what you mean. Okay, here's the thing. You can find the midpoint and then work backwards from the midpoint. But what I want to suggest is the method I've showed you is a lot quicker. So you're correct. There is another way to do this. You can find that green dot here and then move from the green dot to find the blue dot. But I just think it's going to take longer and more time in this case.
Oh, okay, I understand.
Does that make sense? But you are correct. You can get it that way. Yes.
Okay, thank you.
Cool. So you actually have, I've realized now you have two choices. The one thing you can do is go from B to A and then go from C to H, or you could go from B to C and then you have to go from A to H. But people will choose different ways, but we'll get the same answer regardless. I'm going to go from B to A, but you don't have to. Both ways will get us there. So I think. And then what's this going to be? This is going to be y plus 2. So 6 plus, so I've got a 6 here, and I need to add 8 to that 6. So I should get 14. And then in order to go from -2 and add 2, I should get 0. Now, okay, so obviously I've drawn this out of scale. What this is saying is that the point should be over there. And you can kind of see it now. It looks a bit more like a parallelogram. Okay, give me a thumbs up if you feel like you can find the missing point in a parallelogram. Thumbs down if you feel a bit unsure about that. And again, if you are unsure, remember you can watch the recording and just go back and do it again. So I think that was cool. Okay, now, next type of question. Sometimes they give you all 4 points and they say, show or prove that this is a parallelogram. Now, there's a couple of different ways you can do this, right? And I have a favorite method because it's the quickest one. The one that, okay, I'll tell you all 3. The one way to do it is show that this side is equal to this side and this side is equal to that side. If you do that method, you are using the distance formula. Another way of showing something's a parallelogram is to show that opposite sides are parallel. And if you show that opposite sides are parallel, the way you do that is you show the gradients are equal. Then you would use the gradient formula. And that's good and well, but it takes a little bit longer than the third way. And the third way is my favorite way. And this is where I use the diagonals and I show that the diagonals bisect each other. And in order to show the diagonals bisect each other, I use the midpoint formula. So over here, there is a diagonal called AE, and there is a diagonal called RC. They're not equal in length, but if this is a parallelogram, they should cut each other in half. And the way that I'll know that is if they have a common midpoint. So I want to set you the task of find me the midpoint of each diagonal. Find me the midpoint of RC and find me the midpoint of EA. So go ahead and do that. For those who are a little bit rusty on the midpoint formula, I'll put it here. Find me the midpoints of each diagonal. And let's see what we get, and then we'll have a discussion. And once you've got your midpoints, I want you to let me know what they are. I'll do the first one as an example. So -1 plus, wait, not plus 4. -1 plus 2 over 2. And then 1 plus -1 over 2. Which seems to give me a 0.5 for that one. Okay. And Solvo agrees with me. So we've got one for RC. So that's good news. Now find me the midpoint for EA, which is this diagonal over here. So -3 plus 4 over 2 and -2 plus 2 over 2. And what does that give me? I get a 0.5. Yeah, okay. So then we can say that or we can say, this is what we should say. We should say ACER is a parallelogram. And the reason it's a parallelogram is that its diagonals bisect. You've shown that because they have a common midpoint, this length and this length, basically the green one will cut the red one in half. It's not that they're equal, it's just that they're each cutting each other in half. And that's probably the easiest way to show something is a parallelogram. Okay, so that's my top tip. It's not that the first 2 methods are wrong, they're fine, but this is the quickest one. And I always try to show you the quickest one because time is useful to have spare. Okay, now, are there any questions or comments before I move on? Otherwise, you can take a screenshot if that's helpful. And then I'm going to move on to the next type of question that's similar to this. It is, yes, mate, it is good to write a reason, because that's how you know. For example, if you had used method 1, you would have said 2 pairs of opposite sides equal. If you had used method 2 with the gradient, you would have said 2 pairs of opposite sides parallel. So you must show your marker that you understand why you've proved it's a parallelogram. Yes. Okay. Let's have a look. Let's maybe look at one before I get to that. Okay, let's do this one first. So it says here, show that ABCD is a rhombus. Now, a rhombus is just a special type of parallelogram. It's like a parallelogram plus a bit extra. Sometimes people think of it as a square on its side. But what I want you to do is, in order to prove something's a rhombus, you have to first prove it's a parallelogram. And so what are we going to do to try and prove that these 4 points are a parallelogram? What's the quickest way to do it? It's to find the midpoint of the diagonals. So the first diagonal that I see is BD. The second diagonal that I see is AC. And I want you to find me the midpoints, which I'm hoping are going to be the same thing. And if they are, then I've proved it's a parallelogram. Then I have to prove a little something extra to prove it's a rhombus. But I'll talk to you about that. Let's first check it is a parallelogram. Find me my midpoints for midpoint BD, midpoint AC. So what do we have here? Okay, Simpiwe, we agree. Both our midpoints are, so basically this M is going to be -1, 1. We're using it. Now, here's the thing. Sure, you've showed it's a parallelogram, but to show it's a rhombus, you have to show something else. You have to show not only do the diagonals bisect each other, you need to show for it to be a rhombus that the diagonals bisect each other at 90 degrees. Or rather, the diagonals meet at 90 degrees. What formula do you think I'm going to use to prove that these two diagonals are perpendicular to each other? What tool do you have in the toolkit? From earlier in the lesson, what can you remember? What formula do you think I'm going to use? Yes, Inga, yes. So you are going to find me the gradient of each of the diagonals. And if you show me that the diagonals are perpendicular, then you have proven it's a rhombus. So I want everyone to find me the gradient of those two lines. And then we're going to call it a day for tonight. Well, once we proved it's a rhombus. Aha, Lebo, you're quite right. Okay, so Lebo's asked a good question. Could you also prove that something is a rhombus by showing that it's a parallelogram with two adjacent sides equal? You can, Lebo. The only thing is I'm just showing you what I think is the quickest way, but there are many ways to do this. And I'm just a big fan of the diagonals because the gradient formula and the midpoint formula are nice and quick and easy. But yes, you can use other ways. And sometimes your teachers might show you that too. And that's completely fine. I'm just, because of the space we're in, I'm just using the quickest way, basically. So what do we have for the gradient of AC? We need to go, what do we have? 7 minus 5, and 2 minus 4. So we get 12 over 6, which is 2. Aha, and therefore, this times this is -1. Aha. So therefore, we know that BD is perpendicular to AC. Now, the last thing that we say is we can then say ABCD is a rhombus. And why do we know it's a rhombus? The reason is the diagonals bisect, and not only bisect, they bisect at 90 degrees. So there's two conditions that we had to check. The one was that the diagonals bisect. We knew it was a parallelogram. If the diagonals bisect at 90 degrees, it's a rhombus. You could have also, with a rhombus, you could have, as an alternative, if you had found the length of this side, and you found the length of that side, and you found that they were equal in length, that's also enough to prove something's a rhombus if you've already proved it's a parallelogram. However, I like working with diagonals because the formulas are shorter. All right, everyone, I've done quite a lot because I try to squeeze a bit more into our last lesson.